In this video we're going to talk about the calculation height setting for rooms or spaces. Now this setting has previously existed in the settings dialog under room and area calculations, and now you can see area and volume calculations, but we no longer see the calculation height setting here. And the reason why is because it's been moved to be a type setting for an individual level. So if we go here and look at the types settings, we'll see that we actually have the settings we previously had in the dialog on the individual level types. That gives us a lot more flexibility, but we're going to talk about that a little bit later. Let's first talk about what this setting is and what it means to the volumes that you've defined in your model. So we know that we have settings for a space or a room about what its upper limit is, and we're going to talk a little bit later about what the base offset is. But basically we have a level that it's hosted at, and then the top boundaries of that particular space or room. So what that means is we find a two-dimensional cross-section, and then we'll extrude that cross-section vertically until we hit bounding elements. So in this case we can see here that we have a room that is set to have an upper limit of the third level here, but since it is extruded up and hit this roof as a bounding element, it has stopped its extents right there. So we understand the height, but let's talk a little bit more about exactly what this calculation height means and the impact it can have on the spaces or rooms that you've defined in your model. So if we look at the actual space itself that's been defined, we can see here that the roof is actually cutting in, and this is the example we saw previously where the roof itself is actually down here below the cut plane, which is why we're seeing the roof showing up in this particular view. But what we see here when we select this space is the actual cross-section of the room. And in this case it's fairly simple to understand what's defining that cross-section. It's these bounding walls that exist on the extents. So what's happening is there's a calculation height, and that's being calculated by the system. And at that calculation height we're pushing outwards until we find bounding elements. And that's what's defining the cross-sectional area. So we can go ahead and illustrate what that really means if we go ahead and modify this particular level type to no longer use the computation height, and let's go ahead and set this to something like 4 feet. So if we've gone ahead and set it at 4 feet, we can see that we had no impact on this room here, because again at 4 feet, which would be right about here, we're going to have an even we're going to hit rooms in all directions. Now if we move over to this height, we'll see that we did not, at 4 feet we projected sideways, and we actually hit this roof as a bounding element, which is why we're going to see this gap exposed right here. Now the setting can be very valuable for architects who are required to define areas for just their occupiable space. In many cases code dictates that you cannot have or occupiable space does not exist if the height of the space is, let's say, 4 or 5 feet high. You can't physically stand there. So for MEP engineers or people that are concerned with building performance analysis, we don't want to have open volumes inside of our building because that's going to impact our analysis. So we need to be able to control the calculation height that exists and make sure that we're getting full volumes here. But this is just an example of how this functionality works. In general, with a scenario like this, you could just leave it as automatic and it would work properly. Just an explanation of how the automatic calculation works. And let's go ahead and we'll set our type back to automatic. It assumes a 4-foot default height, and it will use that 4-foot calculation height here in this 7-foot and 5-foot high roof scenario. And the reason why is because the bounding walls for this room extend beyond the 4-foot level until they are cut by the roof. In this example here, the 4-foot level actually intersects the roof, as we saw when we overrode the automatic setting previously. So in this scenario, one of the bounding walls is below 4 feet. And if that happens, by default, the automatic setting will modify the height to set it at 0, so basically right at the level itself. So that's why we're still getting a proper definition of volume here. Now with that understanding, we can go ahead and look at more complex situations where manipulation of this setting can be very valuable.